Okay, so we got a question right here. A student placed two magnets on a holder so that the north pole of one magnet faced the south pole of the other magnet. The arrangement was placed on a sensitive balance calibrated to measure force. Okay, the student held part of a closed loop wire between the magnets as shown in the photograph. When the student moved the wire quickly downwards between the magnets, the reading on the balance changed. Explain how the reading on the balance changed. Okay, so the first thing we can see that we have to explain the process basically, right? So basically the student makes the wire go down. I'm gonna write the sentence as well, but I'm gonna explain the process first, then I'm gonna write the example sentence that you can basically get the idea to get full marks, right? So basically the student makes the wire, this is the wire, right? Okay, I'm just making this point as a wire, right? So this basically the student makes it go down between the poles right here. These are the poles, right? These are basically the poles, right? North pole and south pole, right? Once you make the wire go downwards between the north pole and south pole, right? So basically what are you doing? You are basically cutting the magnetic field lines, right? You're cutting it, right? Cutting magnetic field lines, right? Which basically means that EMF is gonna be basically induced when you cut the magnetic field lines. As we know, EMF is basically induced, right? And now as we know, the wire so the wire will have basically current in it, right? So basically the wire will have current in it because EMF is induced, so wire will have current in it, right? So now we know that once it have current in it, the magnetic field is basically related to it, as per the Faraday's law. Basically it will start to have magnetic field around it right now. Okay, right? It experiences it. Okay, due to the magnetic field, because it has current now, so it will have magnetic field around it, which will cause the wire to go upwards. Why? Because I just explained due to Lenz's law, right? What is basically Lenz's law? Lenz's law is when you like the induced current opposes the change in magnetic field, meaning basically when you move the wire down, it will have current, right? Once it have current, it will have magnetic fields forcing it to go upwards in the opposite direction, right? Because as per that's why we have negative sign in the formula of when we use EMF is equal to negative d and flux. This is the number of turns and this is the magnetic flux, and this is small delta change in t, right? This d means small delta change. That's why we have this negative sign, which basically represents the Lenz's law, right? So due to this thing happening, right, we can say basically as that the downward force on the magnet, the wire that you're providing, the force that you're providing downwards onto the magnets, right, causing the balance read to increase. Okay, whenever you make the wire go down, the reading will increase, right? The balance reading will increase. Balance reading increases, right? So I'm gonna write this whole process in a sentence, right? So yeah. Okay, so I have written the sentence over here. When the student moves the wire down, the wire cuts the magnetic field lines, causing magnetic flux. Okay, yes, that's why how change in magnetic flux, you can say causing magnetic flux or change in magnetic flux, right? Due to which, right, the EMF is induced. Now there is a current in the wire. It will then also experience a force due to magnetic field as per the Lenz's law, which states that the induced current opposes the change in magnetic field, which means the wire will experience an oppose in motion, right? Downward force, this is a definition, right? So you can memorize this definition, right? So downward force applied on the wire with magnets around it causes balance reading to increase, right? So this is an example sentence I have written over here. You can write it in your own words. So this is the final answer.